Find the number of distinct values of x that satisfy this equation. That we're not actually being asked to solve it, and we wouldn't be able to do that anyway. So the way to go with this one is to think about the left-hand side and the right-hand side separately and what the graphs look like. We're going to get roots of -1 and 3 for this quadratic. I can expand it as minus x squared. Then I'll get a plus 3x minus x. That's a plus 2x plus 3. And I could complete the square. Let's find out what the maximum value of it's going to be, because it's an unhappy quadratic. So minus x squared minus 2x plus 3 gives me minus x minus 1 squared. This is in a bracket, minus 1 plus 3. So 4 minus x minus 1 squared. So turning point, or the maximum, is 1, 4, in between the two roots, so that will make sense. Right, then it's a case of figuring out this trig function, which is a little bit awkward. Probably a good shout is to just, this is how I did it, is to try some different values. Because we already know some key values here, like -1 and 1 and so on. So I started with 0. And then I worked my way up. Actually, I went up in halves because things like half pi are really useful because so when x is 0, we're going to get y is equal to 0 because it's 1 minus 1. When x is a half, cos of a half pi, actually it's worth just drawing out the cos graph in radians. Remember, this is pi over 2 here, so it's 0. So I'm actually going to get 2 because it's 2 times 1 minus 0. And then for 1, that's cos of pi. That's when cos hits its minimum. So it'd be -1. So 1 minus -1 is 2. Times 2, we get 4. And then it goes back to being 2 here because you got this point. And then when x is 2, we've got 2 pi. We're back to having 0. And it's actually then going to cycle. So next ones would be 2 and 4 again. I think that's the way to go, rather than trying to sketch, say, cos pi x and then thinking about all the different transformations, going with a little table of values. All right, let's get a good diagram down now. Okay, that's all right. Right, then we'll go up in these halves. Half, 1, 1.5, 2. -1. And then this here can be 4, 2. And the graph on the right is never becoming negative, actually. So let's start with the red curve to start with. We've got 0, 0. We've got a half, 2, 1, 4. And then back to 2, 2, 0. And I didn't do any minuses, but I can see it's going to be carrying on up like that. Then the blue curve, we know the maximum's at 1, 4, so they're going to touch here. And then it's going to hit the axis at -1 and at 3, so there. Okay, and that is basically what we need to work out the distinct values of x. There's going to be definitely 1 here, and then nothing in between until we get to this region here, and then 1 here as well. So when I did it, I just read straight off and said it's going to be 3, and that ends up being the correct answer. The only small point that the answers make, or actually some work solutions make, is how do we know there's definitely only one here? There's definitely only one for the other two, but how do we know that it doesn't kind of come up and maybe go like that and go through more than once? But I think we can see, like my sketch is pretty good, we can see that the blue curve is much less steep. It's not gonna come up and back down. Um, and kind of do that. Although I have not proved it at all, but that'd be pretty harsh to have it actually hit 5 times, for example. So it's not something I would have said, even mentioned if I hadn't seen like somebody else mention it. But it's an important point to think about. Like if we don't know for sure that it doesn't hit it. We'd have to like go into a lot more detail to investigate that. But anyway, the answer is 3.